This is part 3, the final part of lesson 8.1, simplifying radicals. And in this one, we're going to learn about dividing radicals. So as you may have guessed, dividing radicals is the most common, or the complex one. If we look at an example, I just wrote this up here. If we have simplify square root of 2 divided by square root of 3, we are breaking one of the rules in that we cannot have a denominator that has a radical in it. That's the problem. And the problem is not that I have a square root of 2 in the top. That's okay. It's just that denominator that's a problem. So that's what this is saying right here. If we have a radical in the denominator, that violates rule number 3. We can do what's called rationalize the denominator. So if we say to rationalize the denominator, we're going to make the denominator a rational number. This is an irrational number right now. So just as a review, irrational numbers are numbers that are decimals that go on forever and they have no pattern. So the most popular one is pi. That's an irrational number. Square root 2 is irrational. Square root 3 is irrational. Square root 5 is irrational. Square root of 4 is not irrational because square root of 4 is equal to 2. So anyway, irrational numbers are like that. So if we want to make this irrational number, square root 3, if we want to turn it into a rational number, you can't just wave a magic wand and have it be a 3. So we do what's called rationalize our denominator. So what we do, concentrate on this example. So I've got the fraction right there, square root 2 divided by square root 3. I'm going to multiply by 1. Remember that any number divided by itself is equal to 1. And so I'm using that idea right here. So I'm multiplying by 1. But I'm doing it in the form of square root 3 over square root of 3. Why am I doing that one? Because when you look at what happens when you multiply that, square root of 3 times square root of 3 is just 3. And now it's rational. And now it's not breaking the rule. And so that's how I can simplify my radical when I have division, and that's called rationalizing the denominator. Now, when you look at this, you cannot cancel the 6 and the 3. And the reason you can't do that is because the 6 is under a radical and the 3 is not under a radical. So it's like saying, 6 divided by 7. You can't do anything with that. And so that's the same thing with the radicals. You can't do anything with that. You could, if you had something like 2 square root 5 divided by 4, you could simplify with the 2 and the 4. Okay, you could do that. But you can't do something inside with something inside the radical with something outside the radical. This is a lot easier to understand if you actually go through some examples. So that's, of course, what we're going to do right now. Just to remember the rules that we had before. When I said violate rule number 3, I was talking about this one right here. Okay, so we just need to make sure we're not having any fractions in our radicand, we don't have perfect squares, and no denominators with radicals. So if you look at number 32, we are violating that rule that has that denominator. So I don't have a problem with this being in the numerator. That's fine. You can't get rid of all of the square roots because it's an irrational number, so you can't just make them go away. So if I multiplied by 1, that doesn't change the value of the number. If you multiply anything by 1, nothing changes, but it can change the look of it. So what I'm going to do is, because I want to get rid of that, I'm going to multiply by 1 in the form of square root 5 divided by square root 5, which is 1. So when you multiply fractions, remember you multiply across the top. So we've learned how to do that. 2 square root 2 times 1 square root 5 is 2. Square root 2 times 5 is 10. On the bottom, square root 5 times square root 5 is 5. Remember, square root 5 squared is just 5. So what I have is I have 2 square root 10 divided by 5. Before you get too excited and start crossing that out, remember that the 10 is inside the radical and the 5 is not. So actually, that is the correct answer. It is simplified. This one is not simplified. And so it's like when you have a fraction, like if you have 6/4 and you need to simplify that to 3/2, this one is simplified, 6/4 is not simplified. It's the same idea. You just have to simplify your radicals. So let's try 33. If you think you're ready, then go ahead and pause the video and see if you can do it yourself and get the right answer. If not, we'll just do this one more together and then you can try some more on your own. To rationalize this denominator, since I've got square root 3 on the denominator, I'm going to multiply by 1 in the form of square root 3 divided by square root 3. So I multiply across the top, so I'm going to have 5 times square root 2 times square root 3, and then on the bottom, square root 3 times square root 3. So on the top, I'll have 5 times the square root of 2 times 3 over square root 3 times square root 3 is 6. Again, because 6 is inside the radical and 3 is outside, you cannot simplify any more than that. Okay, I was going to have you do some on your own, but I guess this is slightly different, so we better look at this together. So we'll do 4 together, and then you can try 35 yourself. So with something like this is violating rule number 2. Go back and look at your rules. Rule number 2, no fractions in the radicand. So that's the rule that we're breaking right now. We've got the radicand is 25/18, and that's a fraction, so we can't do that. So there's a couple of ways you can approach it, and I can't really tell you which is the right way. It just kind of depends on the numbers and how you see it and what makes sense to you. So depending, you might want to do it one way for some numbers and another way for other kinds. So let me show you a couple different things you can look at. The first thing you can see is, can I simplify that fraction at all? So if I think about 25, that's 5 times 5, and then 18 is 2 times 9. Because there's nothing in common with the numerator and the denominator, I can't like cancel something. Okay, so there's nothing I can do to simplify that. So 25 over 18 is simplified. So that course of action is not possible. The other thing I can do is I can separate this. So I can say that's equal to the square root of 25 divided by the square root of 18. So you see what I did there? I separated it into 2 separate radicals. So now I'm not violating rule number 2 anymore, I'm just violating rule number 3, which has the radical in the denominator. So you can rationalize your denominator like this. Okay, you have a little bit bigger numbers to work with there, but you do have a calculator. So 25, well, square root of 25, I'm just going to go ahead and say that that's 5 anyway, and then 18 is going to be 2 times 9. On the bottom, I'm going to have square root of 18 times square root of 18, which is just 18. Now, what you can do right here is you're going to take out this 3, and that's going to come out with the 5, so you're going to have 5 times 3, square root of 2 over 18. Now, on this one, notice that the 15 and the 18 are both outside the radical, and 15 is 3 times 5, and 18 is 3 times 6. Those 3's can cancel. So your simplified answer for this one is actually 5 square root 2 over 6. So you might want to pause the video and study what I just did in that problem and make sure that you're following what happened. And then I want you to try 35. 35 is a little bit different, but it's the same as well. So you're going to do a similar type thing. Okay, for 35, if you try to simplify the 75, which is 3 times 25, and then over 7, you see that nothing can simplify. There's nothing in common there, so I can't do anything with that. So what I'm going to do is I'm going to separate it, square root of 75 over square root of 7, and then I'm going to multiply by 1. So you should have done that. On the top, I'm going to have square root of 75 times 7. So 75, 3 times 25. So instead of 25, I'm going to write 5 times 5, and then times the 7. On the bottom, I'm just going to have 7. Remember, you cannot cancel those because one's inside a radical, one is not. What I can do is I can take out a pair of 5's. I'm left with 3 times 7 on the inside, and then over 7. Because the 21's inside the radical and the 7 is outside the radical, I can't cancel anything, and so I'm done. Okay, so that takes care of the rest of the lesson, and so you should be able to add, subtract, multiply, and divide with radicals and be able to simplify all types of radicals. So do your practice, make sure you bring your questions, and let me know if I can help you.